Hello, everyone. Welcome to another episode of Tectonic Lounge. Today with me all the way from Saigon A.I. is Andrew. Say hi, Andrew.
Greetings, everyone.
So Andrew and I were talking, and the topic of today's conversation is demystifying AI for people in business. Now, I doubt any of you have heard of AI by now. I know it's only 2024, and AI is not a buzzword everywhere, and nobody talks about AI every other conversation, especially if you run into venture capitalist folks. They don't care much about AI, right, Andrew?
Sarcasm. Yeah, understood.
Yeah. We'll add a sarcasm caption later, but sure. So let's start with this. Give us a little bit about your background and how you got into this mystical world of AI.
Sure. I don't love the word mystical, but I understand exactly the point you're trying to make here. The interesting thing is the world kind of awoke, not using the woke word, but awoke to the idea that AI is like a real and tangible and practical thing for them to use in the last couple years. Before that, it was a word that was emerging, but people didn't really get it. They didn't really relate in any way. All of a sudden, ChatGPT exploded on the market, and they were like, "Oh, well, that's AI. It's not. That's one subset of the whole thing." But to give you some, if you rewind that, I've been working with AI for about 15 years, right? And so AI actually started, 30, 40 years ago, but it's only been because of recent advances on how we manage data better and how we have better, faster, smaller, cooler computer components and processing power and GPUs that have allowed us to actually do something meaningful with larger sets of data so that it is less of a parlor trick and more of something that actually could be applied to legitimate business needs. So the majority of my education has been around, data analysis. We used to have the thing in the industry, big data was the big thing. And then data analytics was the thing. Now AI is the thing, and the language models is the thing. But it really all centralizes around data and being able to pull insights out of it and how to know whether or not the results are accurate and meaningful. And so classic AI, which never was classic until we have to differentiate it from large language models and things like that. But classic AI is all about using statistics and math to find and describe how the data is working so that you can potentially predict what stuff would look like when you've got new data. A great example of that would be, we know lots of things from the stock market. So will the stock value go up or to go down tomorrow based on what we know today? And that's kind of a mathematical exercise. If you talk stock speak, then you'll know things like Bollinger Bands and about moving averages and stuff like that. That's essentially, some of the statistics behind what we would classify as classic machine learning. It's just automating statistics to look for predictions.
So before we get deep into machine learning, classic AI, I want you to brag on yourself a little bit and give the listeners a little bit of a background, where you came from, what got you into AI. You said you've been in it 15 years with data science and all the other stuff. Just kind of brag on yourself a little bit, show off your credentials.
All right. So I've got a bachelor's degree from a cute little town called Westchester in the United States. So bachelor's from there. I went to Georgia Tech, which is a kind of pretty top tier software engineering school in the U.S. And I'm currently a PhD AI researcher with the University of St. Andrews in Scotland, which if I'm going to brag on them and thereby a little bit brag on me, they took over the #1 place over Oxford in the UK last year. So they are a top research university, the oldest university in the UK. And so that's kind of my educational background. The business background is I'm a serial entrepreneur. And so I have founded 8 companies now, 3 of which have gone to acquisition in the United States, which means I tell people on a good day, I know what I'm doing. And the rest of those we won't comment about. But everybody who's an entrepreneur who's worked in the business, if they tell you they've never had a failure, then they have not had a big enough business.
Or they're lying.
So, yep, or they're lying. But the true badge of honor for an entrepreneur is to say, yep, I tried this and here's where I was wrong and I learned from it and I applied those learnings moving forward and that turned into something that was successful. That anybody who doesn't have a story like that, they got lucky or they were not successful. So it's kind of that whole journey of learning.
Yeah. And I very much can relate. Been a serial entrepreneur for many years as well, and have had failed businesses, including deep failures, and we won't talk about 1999 and trying to run a .com in the Silicon Valley. That's a whole other conversation. But okay, so we're going to learn a little bit here, and the perspective we're going to take is, while we're both a little geeky and we can talk tech all we want to, I want to talk about it from how does this make a difference from a business perspective? So you already mentioned stock example. So let's start with defining a few terms in clear ways that will be not confusing. So you mentioned a bunch of things. Let's start with data science. This idea of data science, this idea of working with large sets of data. Give me kind of a business-oriented definition.
So in order to do that, let me go back a few steps with the terminology, right? So a lot of people have heard about big data. What does that mean? That means data sets that are probably too big for you to do anything meaningful with on a single computer, right? That's like a practical way. If your laptop can't handle it, it's too big for your one laptop, then that's probably big data. We pushed and pushed and pushed in corporate world and technology to say, you need to be collecting data about everything, and then you need to be learning from it, and you need to be optimizing the insights that you found from it. This was the big push for big data. So from that, we emerged a couple interesting careers. One is a data analyst. Another one's a data scientist, data analytics. These roles all kind of birthed from this idea that data is exploding and large, and we need people to do things with that data. So a data analyst is the person who takes instructions from somebody that says, I think this is happening in the data. Go and prove that that is or is not. Okay, which means that the source of the idea comes from somebody else. Here's a task. Go find this reality or non-reality.
Prove it or disprove it, right? Yeah.
You got it. That is largely, that's an oversimplification, of course, but that's largely the general concept of what a data analyst will do. Somebody's feeding them the theories to prove or disprove. Right. A data scientist is like the next level up because they follow the breadcrumb of what you find in data analyst work, and they propose, suggest, hypothesize what other questions we should be exploring because they might lead to a new insight that you might not have found. Let me give you a really practical example, which is like a textbook example for data science. The shipping company in the US, UPS, they keep lots of data about the people that are driving, delivering stuff. They've got the internal logistics and they've got the delivery logistics. And one of the most profound and interesting things that ever happened is somebody looked at all of the delivery data and they were trying to figure out how we can make deliveries smoother and faster. And so in the United States, whenever you reach a red stoplight, in most places, you are allowed to turn right on red, and you can never turn left on red. So somebody took all that data and they said, what if we tried to optimize the delivery routes so that we eliminate left turns? That's an interesting concept, and it seems so irrelevant before you think about the big data concept. Like before you have data of where everyone goes, that's like, forget it. You could never even consider looking at this. But when they did the analysis, they said, whoa, we can actually really reduce the amount of time spent, especially the amount of idle time sitting there waiting at traffic lights by allowing people to turn right. So you optimize the delivery routes for people to only make right turns. Seems kind of silly, but it made a huge difference.
And the side effect of that particular study, because I've read it, is it also reduced number of accidents because you have a larger vehicle turning left. You often don't see a person coming. Often people run red lights, all these other things. So, yeah, I remember that particular case study, yes.
Yeah, and so that's a really good example of a data scientist looking at the data and trying to solve problems that were fed to them, but then trying to think outside of the box and say, well, what if I just rethink the conditions by which things should work. This is what data scientists do. They come up with the theories that might pay off, and then they, with their data analysts, seek to go prove or disprove those theories.
So I appreciate your definition of big data, and I know that's a term that's kind of gone out of vogue and has got replaced by other things. Just for the sake of listeners, I would say there are two ways the data becomes too big to handle, not too big to fail. One is just sheer volume of data, like the number of turns the driver would make would be sheer volume. The other one is the speed of it is incoming. So with stock transactions, right, or stock volume, it's not just the fact that there's so many transactions happening. It's there's no way your own computer or even your own server can keep up with it because the sheer volume of transactions is so numerous. And so we're getting to that situation. We're not talking about something that you can handle on a spreadsheet, right? I think it's all fun to play with spreadsheets. Right. I think, you can have, I remember an intern saying, I have way too much data. I have over 1,000 rows in the spreadsheet. That's cute. That's not big data.
Yeah. And for anybody technical that's listening that wants some of the more geeky terminology, data is often categorized with, I think they call the 3 V's, which is variety of data, different kinds, Word documents, Excel sheets, CSVs, JSON, etc. Veracity, which is the complexity and structure of that. And what you just mentioned, velocity and how fast it's coming. And so when you talk about those 3 vectors about data, the larger any of them are, the closer you get to this concept of big data, or the more you need to design a system that is smart about how it handles the processing of that data.
Okay, so let's keep going with some terminology. I want to remove a couple terms from our, the noise of our conversation. The term analytics has gotten thrown around, and we've worked, as a web development company with Code Engine Studio, we've worked with analytics for a long time. But mostly when people refer to analytics, they look at things like Google Analytics. And while there's obviously a volume of data that Google processes in the big data sense from the all web traffic, when it comes to your personal website analytics or your company website analytics, that's not what you talk about when you talk about analytics, and you're not talking about with analysis. That's a different ball game, right? That's just a very small subset of data.
Yeah, well, there's a couple buckets of how you would define that. I would say that maybe 90% of the time when people talk about analytics, what they're trying to talk about is a post-analysis, which means stuff happened. Here's a pretty set of charts or tables that summarize to you what happened, right? So that is the majority of analytics, especially the old classic term, meaning more than 4 years ago, term of what is analytics. Here's a summary of what happened in a compressed, pretty visual format so that business managers and executives can get a quick understanding, of the large amount of data summarized.
Right? And this will allow you to make decisions, but at this point you're asking humans to make decisions based on the summarized set of data.
That's correct. And the important thing to clarify there is this only allows reactive response to that data. Here's what happened. What can we learn from what happened? And therefore we hypothesize, we propose what maybe we could do to make it better for the future. That is a human effort.
All right, so let's throw one more term, and then we'll move on to other more AI-related terms. I know there's products out there like Microsoft BA. There's a few other, just BA tools, business analytics tools, business analysis tools. How does that fold into this whole picture that we're talking about?
Well, again, the majority of the tools that are out there, and because there's heaps of them. There's Microsoft's tools, and IBM's got tools, and there's Dataiku, and there's Databricks, and there's all sorts of tools that are out there. It's less about those tools are for this kind of analysis, and it's more about what do people use them for. And so I still go back to say that 90-ish% of people, when they talk about analytics, they're using any of these tools, but they're doing it for post-analysis. They're looking at log files, they're looking at things that already happened, and they're trying to learn what went well and what didn't go well from the past.
Okay, so let's pivot from reactive to, let's talk about machine learning, because I think that's a term I believe is a very incredibly powerful concept, and I think it's very important within the industry, but I think it's gotten lost in the noise and all the content out there that is AI related. Walk us through again from a business owner's perspective. What is machine learning? What is the value, and how does it help us? How does it help us look forward?
Okay, so to compare and contrast to analytics, which is looking at old data and give me the truth about what happened. The purpose of machine learning is to solve a handful of critical problems that allow you to kind of forward think. So for example, let's go back to that stock example, right? We know that the stock behaved like this over the last 2 months. There's a certain amount of volume. It went up and down a little bit. It had some market indicators. Things happened, and there was a result, which is stock price went up, stock price went down. So wouldn't it be great if we had some way to look at that data, learn from it, and to be able to say, based on the conditions today, we think the stock will go up or go down tomorrow. Will it go up or down over the next 3 or 4 days? If we could find a meaningful way to answer that question, all of a sudden everyone becomes stock traders, right? Because it's a way to read the market, respond to it, and know what's coming, right? There's a reason why there's a thing called insider trading, which is, if somebody's about to do a big deal or sell some stock or split stock, things like that, it's illegal to tell the public, because then they would know that there's going to be a change in the stock market and everybody will buy or everyone will sell. Right? So when there's truth that's known about that, it's protected. People are trying to find the behavior of the market and to turn it into a prediction. This is a classic example of machine learning. All right. So I'm kind of dancing around the explanation to help give you some context here. But the idea is what we use statistics, purely mathematical statistics, to look at the data that's happened so far and to use that to find a meaningful way to make a prediction about what will happen today, tomorrow, the upcoming next few days, and predict whether or not it's going to go up or down. And whenever you try to define machine learning, here's the way I would define this. I would say it's a way to automate statistics to learn from data and then make a meaningful prediction about new data. So in the situation where we're talking about stock market, all the data up until today is old data. So we're going to learn from that. Tomorrow is new data. We don't know what the stock price is going to be. We know it's tomorrow, and we know a little bit about the market because we can look at today, right? So the question is, learn from everything up until today and then try to predict tomorrow. Right? So you have some data, but not all. Can I predict that the price will go up or price will go down? And really interesting thing when we're talking about machine learning, you're either looking for a number. For example, if the stock for something today is $97, I want to know, is it going to go to 98? I want a number. I want to know that the prediction is that the price is going to go to 98 tomorrow. Okay, that is a kind of a regression problem, which is I'm looking for an actual number of the prediction. It's not 97 today. I think it's going to predict it's going to be 98 tomorrow. So when you're looking for a real number, that's kind of a regression problem where you're looking for a legitimate number of the output, as opposed to a classification problem, which would be, I'm going to predict whether or not the stock's going to go up or it's going to go down. I'm not predicting how much either direction, but I say based on things, I want to know, is it going to go this way or is it going to go that way? That's a classification problem. Mm-hmm. Again, compared to regression, which is it's going to be 98 tomorrow. You can imagine with something like the stock market, classification is going to be a lot easier to be accurate than regression.
Right. You don't want to necessarily hit the number. It's the idea of somebody explained a long time ago is the roulette table. There's a lot less risk to bet on red and black as opposed to bet on a specific number.
red and black would be classification. 11 would be a regression.
So just again, for examples of machine learning, what are the things that you can learn other than just data points that are numerical, for example, or data points that are even text-based? Because there's a lot of conversation right now about, we won't talk about certain countries, but there's a lot more media-based machine learning, image-based machine learning.
Yep.
let's kind of dive into that, because I think that's both exciting and overwhelming at times for business folks. Is when you're no longer looking for a number, what can you use machine learning for that is beneficial visually, let's say?
So the majority of machine learning, I'll say majority because there are some interesting outliers in this example, but the majority of machine learning requires any type of data that you are going to work with eventually needs to be translated back into numbers anyway. So if we're going to talk about like facial recognition or classifying a picture, is it a cat or is it a dog? Those kind of use cases, you're still turning the pictures into a series of numbers, into a grid of numbers, and you're still, using mathematical methods to kind of look for patterns and structures that do things. The difference would be like driving car technology and stuff like that. The technology they use is not exactly machine learning. So something called computer vision, which is actually more core of an AI algorithm than it is classic defined machine learning. And that is actually taking pictures from the camera, cutting out shapes, and then classifying them. And so that is not the same thing as automating statistics. Mm-hmm. That is actually algorithmic slicing and dicing of the picture, and then classifying the shapes that you found against a list of known stuff. So when you're talking about classifying cat or dog, you've got, 10,000 pictures of cats and 20,000 pictures of dogs and 2 pictures of birds and any other weird things. And then you're converting them all into numbers. And then you're feeding them into a pretty complex table of data. And then you're probably using something like a deep learning or a neural network type of a machine learning algorithm. And its job is to look for patterns that match. And so, for example, cats will have bigger whiskers and they'll have upright, pointy ears. And so what's interesting about that is that if you've got a dog that has upright, pointy ears, then it's more difficult for that model to predict that they're a dog rather than a cat, because the characteristics align closer to the patterns that you found when you look at and learn from cats. It's not unlike the way kids learn. So like when you've got a really small child and the first time you're outside and you see a cat or a dog, they go, "Ooh, horse." Why? Because they saw a horse in a book and it has four legs and it's got a head and it's got a tail. Okay. And you say, no, that's a cat. Okay. So then the next week you go out and you see a dog and they go, "Ooh, cat." Close. Okay. But then you have to explain the unique differences between cats and dogs. All right. And then you might go out and you might see a ferret in a pet store and they go, "Ooh, dog." No, it's again a little bit different. And so you keep like evolving your definition. And so the way that machine learning works is by better examples of quintessential definition of what those animals are, allows the statistical analysis to be more accurate.
Okay, so we can recognize dogs and cats, and hopefully horses as well. The last one, before we get into some of the more modern situations, you mentioned the word algorithms, and I know that every person who took computer science 101 and any kind of programming class had to learn something about algorithms. Let's make it simpler for business folks. Are algorithms part of AI? You mentioned that algorithmic processing AI. Are they essential for AI, or are they, almost opposite of AI? Because people sometimes seem to think that if it's an algorithm, then it's not thinking; it's just following rules.
So I understand exactly what you're asking. I would define an algorithm as a strategy.
Okay.
And so when you think about this, if you're going to take apart and rebuild a carburetor on a motorcycle, okay, there's a strategy you're going to have. The outside casing has got some bolts. You're going to take it off there. Part of your process might be to have the book and look at the diagram, and you'll take certain pieces out, and then whenever you put them back in, you need to put them back in the right order. Okay. If you don't follow that process right, the chances of having a good result are pretty slim, right? So another way to look at it is like a recipe. All right. whenever you make pancakes, there's a specific order. When you bake biscuits, there's a certain order. Whenever you're mixing ingredients, you kind of have to do it in the right order. When to mix, when to let things rise, okay, how long to bake it for, and at what temperature. If you try to do it in the wrong order, your result isn't the same. I'll give one more example, all right, because I think this starts to give you a bigger picture of what we mean when we talk about algorithms. There are multiple ways to assemble a jigsaw puzzle. Absolutely. How many ways? Well, if there's 100 pieces, then it's 99 factorial.
Right.
Right? To get mathy geeky, right?
Thousands, yeah.
Lots and lots and lots and lots and lots of ways, okay? But most people have a strategy, okay? So, like for me, example, I separate all the edge pieces. And then I look for the corner pieces. And I start with the corner pieces, and I start to build out the edge pieces. Why? Because I eliminate 25% of the unknown by having a flat edge, right? That's a statistic for you. I statistically am likely to get pieces to fit better, and I reduce my error by 25% by looking at the edge pieces first, all right? So my strategy is assemble all the border of the edge pieces. And then I look at the picture that I think that the edge starts to draw, and I look for colors that are similar. And that reduces, 10% or something like that to get there. So I'm making educated guesses instead of random trial and error.
Okay.
That defines a strategy to help to reach the goal.
Right.
Yep, an algorithm.
So how does that fit in with AI then? Because obviously in AI, you're trying to get the artificial intelligence to make those decisions.
Yep. And the vast majority of those will use statistical mathematical methods to try to fit mathematical formulas to the data so that it can find the best way to assemble. That's not how every one of them works, right? But that is pretty much how all machine learning works. And if we take a step back and we say, how do you define AI compared to defining machine learning? I think now is kind of a good place to try to do that. First of all, AI is like the big circle, right? Artificial intelligence is this gigantic thing. If you think about a Venn diagram, machine learning is like a subset of the big, right? So what makes up the rest of that bubble? So machine learning is statistics, automating statistics. Well, what makes up the rest of it? In my experience, it's a collection of smart algorithms or strategies that solve problems, right? And that's, you can't really define it that much more because it's a really disparate collection of weird tools. Natural language processing, NLP, computer vision. They both belong in the umbrella of AI, but they are nothing like each other.
Right.
And they use radically different strategies to solve very different problems. So you can't really group them together with commonality other than they live underneath this umbrella called AI. So when we talk about AI in that regard, it's just kind of like the big collection of tricks up our sleeves to have unique ways to solve difficult problems. That's really a very vague description, but there's not much better way to describe that big circle that covers all.
Okay, so then within that circle, you use the term classic AI, which, I'm laughing at the terms classic and regular basis because I was staying in a hotel and I saw enjoy classic animation, and I'm going back to the 90s and 80s. And I didn't think of that as being particularly classic per se, but that also ages me a bit. So what is classic AI? And I understand that we'll need to contrast it with the next thing we'll talk about, but kind of give me your definition of classic AI.
So I kind of draw a line in the historic timeline of AI with when neural networks, which is a machine learning algorithm that was loosely modeled after the way the neurons in our brain work. And that's been around for 20, 30 years or something like that general concept. But at some point in time, the late 90s, early 2000s, people decided we can take this concept and we can make it really, really big, which is, throw a lot bigger computers at it make it a lot more complex inside, and make it work on bigger problems. That turned into what we call deep learning. All right. So I kind of draw that line and say that when deep learning started happening, that kind of starts this new era of next gen AI machine learning. That's where I loosely define that. And I say that anything that happened prior to that is deeply mathematical, is deeply statistical, very predictable, very explainable, and that's an important term, very explainable, which means that you write your machine learning model, Classic A.I, all right, you have a result, and if you need to go back and mathematically prove how and why I got that result, it's reasonable to do so, right? Because you can follow the math backwards. As soon as we started getting into deep learning, and again, just to help a little bit of classification, a neural network, a simple neural network maybe has 5 layers of neurons in a row that look like a matrix, and data all flows through. You've got inputs on this side, outputs on that side. So a reasonable classic neural network might have 5, 10, 20 layers of columns of those neurons in the spreadsheet. Think of a spreadsheet that's got 20 columns. Got it. All right. A typical deep learning model might have 10,000, 20,000, 100,000 columns. And so it's really the exact same technology, just on steroids, right?
On scale,
massively
yeah.
more complex. Yeah. And so the difference is, if you've got 20 columns of data, if I have to go back and hand trace the math between them, I can do it. You know, nobody's going to enjoy sitting there and hand tracing that stuff backwards, but you can do it, right? But you give me a spreadsheet with 50,000 columns doing that math, and you ask me to hand trace it, forget it. This starts to become a serious problem. And here's where we got the terminology where some AI models are a black box, which means inside is so complex, data goes in here, data comes out there, and you kind of just have to trust that it did it right.
You hope it's right.
It's not easy to explain, hence the definition black box. What happens inside is something magical. In goes something, out comes something. Wow, look, it's magic. Black box definition, right? So when getting back to that core question of how I define classic versus new level AI, I would say if it's explainable and it's based on core math, then that's probably classic AI. And so when we're talking about heavily complex models that are not easily hand traced or explainable, or are based on too much randomness such that there is not a clear understanding of how it gets to that result, that's kind of this new world of AI. And that's where your language models fit in. That's where your deep learning falls in. That's where some computer vision falls in, especially because we have something called multimodal, which is maybe I use one classic model and I use one deep learning model and I use some computer vision. I use them all together. Mm-hmm. So those start to become prohibitively difficult to explain their answers.
Okay.
That's how I would help. Does that help with that definition?
It does. It helps a lot. I think we're getting into what I would call the mystifyingly scary category. Really fast, I want to kind of debunk, since we're talking about business, I've seen way too many things. And I mean way too many. There's a, email automation tool that says AI driven. And I ask them, what is the AI inside? And it's just automation. It's just, we scheduled 7 steps. I'm like, guys, come on, that's not AI.
It's magic. They don't explain it.
Yep. Yeah. So I think we need to be careful as business people and believe that everything is AI driven. I think a lot of things, because it's such a buzzword and because everybody wants to invest in AI and claim to be AI powered, a lot of things that are claimed to be AI are simple algorithmic things or even simple automated tasks that I wouldn't necessarily call AI, because it's not making decisions, not analyzing data. It's not doing more than just, follow the 7-step process. So you mentioned language models. I don't want to get too deep into this. I know we have the natural language model processing, right? Which has been around for a while. It's a lot of the text to voice that is, I remember my supervisor back in 1998 was trying to use DragonSpeak, and
Yep.
was so mad at how bad it was interpreting things and how much correcting he had to do. And yet today I'm able to do voice to type at about 90% accuracy, even, no matter how tired I am and all the other stuff. And I've noticed people with accents are able to use it. So it's gotten a lot better. So there's natural language processing. And then there's the new, which is the large language models. Give us some really basic, again, non-geek orientations there.
All right, you're asking tough questions here, but the good news is that the way I teach the people in our company is I always start with the intuition of have a clue about how it actually works inside. So I got a lot of good examples for these kind of things. How the basics of NLP works. NLP, by the way, is its own little collection of many, many, many types of tools, right? For example, I know some people doing research using NLP that listen to dolphin squeaks and try to convert that into comprehensible language. Pretty cool stuff. And they use pretty interesting mathematical formulas called Markov chains to kind of follow and sequence and things like that. But that's a little too geeky. Let's talk about the basics. The basics about how a simple generative natural language system would work is to say that if I give you a fragment of a sentence, okay, Andrew drinks blank in the morning, okay? You can call this a prompt to use ChatGPT kind of terminology and things like that. Yeah. But you can even go back. I mean, I have technology code that was written 15 years ago that can solve this kind of problem. Here's how it works. Andrew drinks blank in the morning. Okay. Well, there's only a certain number of words that could potentially fit in that. So what we can do is we can say, hey, we're going to digest a corpus of text, a book of text. All right. Let's say, for example, we're going to take the works of William Shakespeare. We're going to digest and we're going to read only the works of William Shakespeare. And we're going to learn about the structure and how sentences work.
Oh my.
Okay. All right. So now we're going to look at all the examples of Andrew. Andrew's not in there. So, okay, we don't have any meaning with there. Drinks. Okay. The word drinks shows up many times, but what is the typical word that follows drinks? Wine, mead, water, things like that.
Poison.
These are like poison, right? So these are like the list of the words that most commonly follow this key, the seed word. The seed word is drinks. What are the statistically most common things that follow it? Okay. And then we can look at that blank and say, in the morning. We can look at it and we can say, if we use the word mead, water, poison, and we can look at what are the words that statistically follow that within that body of text. Pardon. And what happens is when we look at the pre and we look at the post, we can take a pretty educated guess about what word should show up there. Now, if we look at only William Shakespeare,
it is unlikely to find coffee, right? Yeah.
Right, exactly. We're very unlikely to find coffee, even though that is the more reality, the more truth. So at a small scale, just the works of William Shakespeare, now you can understand that it's all a game of statistics. Okay? And all we do is to scale from this concept up to the bigger concept of language models is instead of looking at the single seed word drinks and the single post seed word of in, like in the morning, okay? All we do is we grow that pre-prompt. So it's not just looking at drinks, it's now looking at 5 words, 10 words, 20 words, 1 paragraph, 1 page. The bigger that window is, the more likely we can find some example of something that statistically fits in the middle very well, very logically. This concept, it makes some sense. The larger that corpus or library of text that you're using to train on, the bigger windows of pre and post you can look at to statistically find what fills the gap. Make sense?
So how do we go from NLP to LLM?
I was just describing that, right? So instead of training
Scaling.
on just William Shakespeare, you train on a heck of a lot more, right? So, hey, why don't we just scrape the whole internet? Okay? And you're taking all the examples of stuff everywhere. And now you've got this gigantic library. And so you start to write text you say, hey, write me a story about something. Write me a story about a cat who likes to go to school. So it'll start by looking for statistical words about cats in school. And you'll notice that something like ChatGPT will always use one of your seed words in like the first sentence. Why? Because that's the way that it works. So the cat went to school one day. Now we use this as a pre-phrase, and we look for all sorts of ideas, poems, stories, blog posts, social media, books, or whatever that we've incorporated into our library. And we look for interesting things that statistically follow that. And then we drop that next phrase in. Now we use the whole thing, including that new phrase, as the input for the next one. And this is why when you're typing, it's kind of like chunking bloop, 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 of the new bits, because each time it's using that big block of prior text to resubmit and look for the next phrase while it's composing.
Okay. So one quick question about LLMs, and then I kind of want to not dig too deep in those. Is there, because it's coming up with different chunks, that limits the risk of it just copying? If I just tell me about a Scottish nobleman who, commits this crime with his wife, I don't want it just to copy Macbeth, right? I mean, obviously that would definitely fit into that definition, but because it's doing it a chunk at a time, it's not going to go, oh, look, there's this entire book about this, and makes a copy. So we're creating new content, which leads us into what some would call generative AI, or is that not a subcategory that you look at as its own thing?
Well, we talked about something called a language model, like a large language model, like ChatGPT, Claude, and Anthropic stuff, the Hugging Face, things like that. Those models, well, they can do multiple things. One of them is generative content. Create me content based on this prompt. But they can also be tasked for things like trying to look up facts, or trying to classify information, or summarize existing resources. They can serve multiple purposes. Like we talked in Classic A.I. about something that's a regression. Look for a number. Stock will go to 98, okay? As opposed to classification, will it go up or will it go down? Two different questions, right? But models can serve those purposes. In that same regard, language models can perform certain different things with their library of data. So when we talk about generative AI, so we are just talking about a subset of what those things do, which is, given a prompt, create an original new result that fulfills the core meaning of your prompt.
So it's also doing a subtraction from existing.
Well, it's being influenced by, right? So the great example I like to give people, because you can use generative AI to create new pictures. Make me a picture. You can do this with Bing Copilot. Make me a picture of a monkey typing on a keyboard, wearing a fedora. Okay, easy for it to do that. Why? Because it's got this gigantic library of stuff, and it takes ideas from different places and it composes them into something that looks interesting. Here's the rough idea how that works. If we wanted AI to really know how to recreate examples of new artwork that looks and feels like Monet, then the best thing you can do is you can feed it only examples of Monet. Mm-hmm. All right. Now, if you train that model and it's only ever seen Monet, and you ask it to create a picture that looks like Salvador Dali, sorry, it can't do it. Okay. It's going to try, but it's going to end up looking like Monet, yes. Right? Because that's all it knows. All right. And so understanding that general concept, it helps along the way to understand generative content. It's only as good as the broad depth of the data that it has been trained on.
Right. And that's not quite black box in itself, but it is still a mystery to us. Most of us do not know what the heck it's been trained on.
Yep. That's a problem.
You mean there's a risk factor in not knowing what you're getting answers from? Oh, come on.
I love to tell people, like I mentioned, I'm doing research with the University of St. Andrews, and my field of research is about the intersection of education, psychology, and artificial intelligence. how we can find a way that AI can be a better teaching assistant, for certain use cases and problems. And the example I'd love to tell people is that when new versions of ChatGPT and generative AI come out, I go there and in this field of educational psychology and AI, I'm becoming more and more an expert. I wouldn't say I'm an expert, but this is definitely my field of expertise. So I say, give me an example of the 5 top research papers. I'm asking the prompt to ChatGPT. Give me an example of the top 5 research papers that are the intersection of educational psychology and AI. And it'll give me back a result and say, these are the 5 papers, here are the summaries, here's the DOI links and stuff like that. And whenever I first looked at that, I was like, holy smokes, these are amazing papers. This is absolutely fantastic content. How come I don't know about any of these? And then I clicked on each link and I realized that they don't exist, right? And the idea here is because generative models, the base generative models like ChatGPT, its job is not to be truthful. Its job is to make a creative result that convincingly sounds like it was made by a human. That's its job. Its job is not to give you truth at all. And so as a result, it gave a very convincingly written result to me that made my eyes pop, and then I realized it's all garbage, right? It didn't have an answer. And thus we uncover this concept of hallucination, which is essentially lying, right? The AI,
we're just calling it
the
a nice
ChatGPT,
yeah.
It doesn't know what to say. So instead of saying, I don't know, it says, duh, how about this? This sounds good, right? Because again, its job is to sound convincing, not to deliver truth.
Okay.
That is a problem with what we classify as generative AI.
Yeah. And I think that this is the one where I am deeply concerned when I see that folks are using ChatGPT and Claude and all the other ones as a replacement to search engines. Because not saying search engines are perfect, because you can still find misinformation that has been published by somebody else, right? Or incorrectly studied documents or whatever it may be. But it's not going to be a complete figment of this model's imagination.
Yep. Okay. Well, this opens up a key concept that is good in demystifying AI. There's a lot of noise on there. I think Elon Musk likes to talk about this, and other people like to say, oh, we're getting close to this concept of the singularity where AI becomes more intelligent than humans and we might blend humans and computers together and stuff like that. The reality is that machine learning models, language models, AI models, there is close to zero true understanding actually in the model. So everything that we're doing ultimately boils down to statistical mathematical calculation, which is either based on probabilities or randomness. But there is really very little core understanding. The AI that generates a good text summary about a particular topic doesn't actually know and relate to the core concept. All it knows how to do is assemble a convincing summary of stuff from the library of data that it has available. So the great example of this that I talk about is if you're classifying a picture of people and you're trying to figure out emotion. Emotion is the big tough point when it comes to AI, right? And you got a picture of a woman crying. Well, if you use the vast majority of pictures of people crying on the internet, you're gonna classify that picture and say sad. This woman is sad as the emotion, okay? But you might be mostly right. But in our exact case, you might have had a picture of a woman who's at a wedding whose daughter just got married. And it is not just a little wrong. It's very, very wrong. Because AI doesn't have the context. You can't really get context from pictures. Maybe you can. Maybe you can hope that the background tells you that it's at a wedding. But what if it's a close-up? Then no, you're not going to get context from that background. And as a result, there's no way for it to be able to distinguish and know the difference. And again, the key is it's based on all statistical analysis of the look of that without any true understanding. And that is a very common diagnosis of the whole AI industry. as of 2024.
Yeah, so we had an episode earlier with a gentleman who works in real estate, and they built a tool for management of properties. And he said one of the things that AI has failed to do is handle things like dealing with evictions. And one of the reasons that a scientist gave him is AI doesn't have a comprehension of why would somebody choose to squat, or why would somebody choose to fail to follow the rules of eviction notice or something like that. Well, they've been served 5 notices. Why are they not following those? Well, because we're human and we don't do things that always make sense. So I think that's a powerful thing to consider. So in our previous conversation, you mentioned the idea of the current AI, the LLMs, are a transitional model. What are we transitioning to?
Good question. Let me first kind of clarify what I mean by transitional, and I would classify it as transitional technology, and that's a broader term as opposed to talking about an AI specific term, transitional model. I'd say it's transitional technology. Pardon. And what do I mean by that? If you remember, Web 2.0 and all of a sudden there was this concept of new content called Web Splash, which is vector art that could be animated. It turned into Macromedia Flash and then Adobe Flash. And we had all this animation that started to show up and bring rich stuff to the web. That was a transitional technology. Why? Because it was new, it was fresh. You had to use weird plugins to make it work for most people. It was really clunky and caused more problems for businesses that tried to adopt it. And fast forward 8-10 years, totally eliminated, totally obfuscated, removed, and gone, and forcefully pushed out of the market in favor of HTML5 and newer technologies built onto that. All right, that's a little history lesson for classic web, which means more than 5 years ago. So I classify that as transitional technology, which is exploding on the market, not yet quite proven its long-term value, and quirky enough that it can't quite prove all of its ROI in order to be a long-term value. That's more of a business definition around the technology. So when I look at language models, it fits all of the same criteria. It exploded on the market. All of a sudden, the big tech players say, ooh, how quick can we get this integrated into Google Search, into Microsoft Bing, into other places? How quickly can we get it into iPhone? How quickly can we get it into Android phones? And it was only after they started pushing that they realized, oh boy, it's answering things in a really weird way that is not very predictable because, oops, we don't really understand it. There's articles out there that talks about how Google doesn't fully understand, their own Gemini model and its results. CEO of OpenAI says we don't fully understand how the explainability about how our model does all its things. This is scary stuff. When you've got the leading market companies pushing technology to consumers and they do not fully grasp the how and the inner workings of the technology that they're selling, that's scary. That tells me that they don't fully understand the impact or the value of that. And typically, prior to the last decade, companies would spend a lot more time understanding that and justifying it and testing and even do test marketing a lot more before they would release such technology that radically changes people's behaviors. So the fact that we still have hallucination problems, lying problems with language models, I love to talk about this example. Catholic.org released an LLM model where they I forget the name of it, but they said it's a priest or a father something, which is this LLM model that they trained on all of the data from the definition of Catholic doctrine. And so somebody posted an example and they said, Father Bot, whatever his name is it okay that we do baptisms using Kool-Aid? Right? Now, any human that has any understanding would go, come on,
yeah.
Come on now. This is a common sense issue. All right. Come on. All right. But the AI responded and said, while it's not orthodox, There's no reason why you can't do it. So it basically said yes, right? Now, the people that designed it, that support it, they kind of laugh it off and say, yeah, well, it's not necessarily technically wrong. If there's no water available, can you use Kool-Aid? Yeah, okay. All right. So it's not, from a definition of liquid perspective, which is about the depth of the understanding of the AI, you can understand why I came to that conclusion. But it's a good example of the fact that the lack of understanding means that there will be a lack of common sense. And if you ask my opinion about the viability of whether or not it's good technology for people today, I would say an AI that doesn't know common sense ought not to be making an easier set of advice to its users whenever that advice may not include common sense. That's not necessarily what I think people need. They're trying to simplify and make their lives more convenient with AI, but they're getting a dose of lack of understanding, lack of common sense. That doesn't feel wise from a, big picture of good for humans perspective.
Yeah, I would go back to my grandfather years ago who kept telling me common sense is not that common. And I think every generation assumes that the next generation does not have as much common sense as they did. And we can talk about skill regression and skill development. I think that's a psychological conversation that's worth a separate series of podcast episodes for somebody who's more trained in psychology. But I do think what you're saying is very powerful in a sense of it is a convenience tool. And I think we've all found ways to save ourselves time by generating emails or images of monkeys and fedoras, on a typewriter or whatever it may be. And I think as long as we understand that it still needs that human touch, a human review, and that human common sense application, I don't really see an issue with using it as a tool, right? Just like I have a hammer and I have a screwdriver and I don't use them the same way.
Yep.
That's going to create some very damaging problems if I were to do that. So I would say it is important for us as humans to evaluate those. So let's bring it back to practical application, right? We often do this in different types of study where we have the theory, we go through the depth of it, and then we bring it to application. Speaking to folks who run businesses who are technologically aware, obviously you cannot avoid AI today, no matter where you look. Just the terminology and the marketing is out there, and with understanding the risks. And again, I want to stay away from all the risks to the young people who have not developed the
Yep.
the things. And I think those are very important issues that should be discussed, particularly in educational settings and parents and so on and so forth. But we're going to focus on the business folks. What would be the top 3 things you'd say are in today's AI world you should grab onto and take advantage of that exist out there?
Got it. I'm going to classify all of these as tips for people that are in the workforce that are trying to maybe avoid that scary thought of maybe my job will be taken by AI, right? So what should you do in response to that kind of a problem? The first one is get educated, right? And try to find meaningful sources of people who aren't trying to sell you a product, right? Try to find meaningful sources of people talking about it to help you understand things that you can do. And the reason why you should do that is because if you are willing to learn and change, that massively will reduce the risk of having your job changed, shifted, eliminated, or lost due to technology changing. So one is to get educated and stay educated, right? That means
Continue
that make it part of your life. Make it part of your life to continue to reinvent yourself with new skills related to the new technology. The second thing I will say is that there are heaps of very, very useful daily practical tools. I think if, like you said earlier, if you know the right context to use ChatGPT, it's an extraordinary tool. So if you want to write a marketing blurb for something, writing a prompt and having it generate text for you is extraordinary, so long as you don't take the result and copy and paste it and fail to use your own brain. Okay? So use it as a tool that inspires, that kind of pushes you through writer's block.
Absolutely.
this is a fantastic way to use that kind of a tool. The next thing I would say for maybe people who do graphics design or work with graphics designers, AI is a very imperfect tool when it comes to generating graphics and stuff like that. And in the same way I just described, to use ChatGPT to inspire or to break through writer's block, use it to inspire, to influence, as a muse of ideas that you can feed to people that can do things. I'll give you a practical, really good example of this. You can say, generate me a logo for a music event that I'm doing that uses the text Cafe Jam. Why? Because I happen to have a music event that I call Cafe Jam. And I've done this. Make a logo that does this. And so it comes up with a great picture, and then the text that's in the picture is spelled wrong. Okay? So maybe I love the logo, but the text is wrong, so I can't use it. Well, I either have to be an amazing graphics designer and to go and edit that picture and fix the text myself, okay? Or I'm thinking about it wrong, because the generative AI for a picture is not meant to be the final product. Instead, what I do is I generate that idea and I send it to the person I work with and say, hey, this is really close to what I want. And this inspires them, this allows them to make it, and that person who makes it has the full access to the resources to be able to change all the elements, that if I need to tweak and adjust things, I can do it. And they can make sure the text is right? So once again, getting back to this core concept of use AI to inspire your ideas, to speed up your thinking and your concept modeling, but try to remove this idea that AI is going to produce a final product for you. And so if we stitch all of those things, I don't know if that was 3 or 4 things, but we kind of stitch all that together into a pretty practical way of thinking, which is have to keep learning, learn the new tools, adapt them and apply them to the way I'm doing. But the result of what I say is done, the result of what I share out or I publish to a website or to a blog ends up being the result that I finally refine whenever I'm done. And that's what I send.
Okay, so we've looked at the positive ways, and I would say for me personally, I also love the idea of saving me time by doing things that are redundant, including like summarization, right? You know, I have tons of web episodes that I record. Sometimes it's great to inspire me. Again, the final version is going to appear under the video on YouTube that we're going to post with you there is not going to be written by AI. Now, they're going to give me about 5 or 6 versions. I'm going to sit there and tweak them till it makes sense to me, right? So I think, but it summarized the information well and gives me a starting point for a lot of things that I'll be doing. And I think that that's a great way of looking at it. Okay, yep. So we've looked at the positive. Let's look at the awareness of risks. What are the top 3 things you should be aware of? And I think we mentioned one already, which is don't be assuming that it's a final product. Yep. But other than that, what are the 3 things you should be aware of as a business person, as a person in the workforce, particularly as a person, an entrepreneur, somebody who's trying to develop a product? What are the things you need to be kind of on alert for when it comes to AI?
Got it. So I'll answer that question with a little bit of a story, all right, that I hope will catch the general concept. The general top level idea here is that AI is imperfect, right? So if you spend lots of time to solve a problem, maybe you could classify your result as an A+ type of an answer, okay? You should not expect AI to be able to give you an A+ answer, right? So whenever you are delegating the majority of your effort to AI, you end up with something that is maybe closer to a C+ type of an answer. You have to know that that's likely going to be the outcome. You might get lucky and it's better, but you have to go into it assuming that. Now, let me give you 2 frames of references for this. In the AI and machine learning world, we have this concept of something called a confusion matrix. What does that mean? We've created an AI model, a machine learning model, and its job is to say, this is cat, this is dog, or this is neither. So then after we run all of our tests with all the data on the model, we end up with a list of results of where it got the questions right, where it predicted correctly, it predicted incorrectly, and whether it was a positive or negative class. Let's say cat or not cat is a classification. So you have this thing called a true positive. I have a picture of a cat, and I predicted that it was a cat. Okay, and you got a true negative, which is something. It's a picture of not a cat, and I predicted that it was not a cat. Cool, that's good. But then you've got two other use cases. You've got false positives and false negatives, where false positive is something that says, this is a picture of a dog, but I predicted it as a cat, right? And then false negative is, I've got a picture of a cat, and I predicted it as not a cat, right? So that's what confusion matrix is for. It's a very powerful tool for data science analysis and interpretation of how well is a model working. Here's why this matters. Mistakes are the problem, right? We already know that AI isn't perfect. That means it makes mistakes, okay? Some mistakes are worse than others. The classic textbook example is, if you've built an AI that looks like at a chest x-ray scan in medical terms, and it's trying to determine whether or not you have cancer, all right? Well, if it looks at the picture and it says you have cancer, but you don't,
Oof.
that's a false positive, okay? What's the consequence of that? Well, the doctor is going to start giving you medicine that you didn't need. And they actually take somebody who's healthy and you make them sick, all right? So as opposed to somebody that is that's false negative, so somebody has cancer, but the system predicts that they don't, okay? So the point is that neither one of them is good. If the AI model was right, it would always get it right, but it doesn't, all right? So now you have to ask yourself, which is worse, the false positive or the false negative? Okay, well, the truth is the false negative is not as bad, because hopefully they're going to be getting additional screenings, and then in the future they'll catch it. Or other symptoms will make them go, well, the test said no, but it sure looks like it, okay? As opposed to the test said yes, here's your medicine, oops, we made you sick, and cause new problems. So in the medical context, falsely diagnosing that you have cancer is horrible. So when they test their models, they will make sure that they avoid false positives at all costs. That is the most important metric. And it is better to be less accurate and have fewer false positives. That's interesting. So when we think about this as a whole for all of AI, all you have to do is put yourself in the context and say, hey, I'm going to see my doctor. My doctor says, we're not sure what's wrong with you, but we're going to use this new AI. And this AI is going to tell you what's wrong with you. Well, you can ask that doctor and say, oh, before I pay and use this AI, can you give me some research results that kind of tell me what the results look like from using this tool? One of two things is going to happen. Either the doctor is going to say, yeah, I've read them, and here's a copy of the paper, you can read it, and then you tell me whether or not you're comfortable to use that. Or the doctor is going to say, oh, we really don't have that. This should give you a really good feeling in your gut about whether or not you should be trusting that kind of an AI. This concept is very personal to you based on your health, or think about it like, oh, I took my mom to the doctor. The doctor wants to use this AI but can't answer that question. Okay, now you got an even stronger feeling about, or intuition about, the trustability of that technology. Take that concept and bring it into your business. Okay, someone's trying to sell you a product. Well, what's it look like if it answers wrong? Okay, what's it like if it misses something that should have been predicted? Think about what the results are and what the impact is, the consequence to your business. Also knowing that if you say, oh no, it answered wrong, it says that you can get baptized with Kool-Aid. All right, what if it answers something like that? What do you do about it? Okay, if it's a human that made a mistake, you simply go have a meeting and you tell them, no, you said this wrong. Oh, got it. I'll make a note. Now the next time they've changed. But with an AI, you have to go through this whole process of retraining, retesting, a new way of monitoring. You may or may not be able to fix that problem quickly, which means the problem might stay there for a while. So you've got issues like that you really need to care about. So it really all comes back to the same core concept of, it's not 100% accurate. Know the risk if it doesn't do things right. That's the best advice that I can give to people who are in the business context of any type of AI. What happens when it's incorrect? What do you do? How do you deal with that? How do you respond with it? Are you just accepting answers from AI, or humans, reviewing it? Are they going to catch it? Those are all very, very important questions.
So I'll sum it up this way and tell me if I missed anything, because I think it's very important that we use our critical thinking skills here on a regular basis. I think there are ways AI is going to save you time by optimizing some of your tasks as a business owner, as a person in the workforce. Do things that particularly were difficult. I'm a person, when it comes to writing, struggle with starting something new. I've written several published articles, and it probably took 80% of the time to get started and 20% of the time to finish. So that is definitely a huge help. But I also would not assume that I can get AI to do all my work and work, 5 hours a week, because everything's going to be perfect and just output all the beautiful results. In reality, we're shifting our efforts to the critical thinking process to be able to evaluate the responses and also to keep ourselves updated, which I think is wonderful, because our human brain's an amazing creation that is much more of a mystery than the black box of AI, as much as we study the human brain. But the neural networks there are so much more potent than the trained ones that the computers have. And I think it's exciting to see how we can enhance some of the processes, but still leave the human intuition, the human experience, the human emotion, and then the human critical review process intact. And I think that's a necessary step. So while there's things that's going to free your time on, you need to make sure you're investing that time in ways that will help you be better while utilizing the tools.
Yeah, I think you exactly got it. It's great for creative boosting and assistance to inspire, and it is never a replacement for output, for human output. That's the way I would view it. Yep.
And I think as long as we have a healthy relationship with that concept, we will avoid many of the risks. What scares me a little bit, and again, the beautiful thing is I'm not in control of this world. I did not get assigned that job, and I'm very good with that. There's a lot of people who forget that part, that we need the human touch. We need that, we were made to be creative, not necessarily to just rely on machines. But Andrew.
Yeah, I was just going to say, one of the most beautiful things about this world and about life is that the things that we produce have flaws. I think that's the most interesting thing. If we try to make everything too perfect, it becomes boring.
I agree. Well, Andrew, thank you very much for your time. For everybody else, you were listening to Tectonic Lounge. It was a great episode. We were trying to demystify AI, particularly for business folks. There's a ton of information to process. I'm going to have to re-listen to it more than once to get everything. I recommend you do as well. And please tune in to future episodes of Tectonic Lounge as we bring in folks like Andrew to share wisdom with us, both from their broad spectrum of knowledge as well as their specific experiences in their businesses. Thank you very much.
Thank you.